Hey everyone, in today's lesson we're going to be talking about scripting inside Unity. So scripting is where the magic happens. This is where your game logic goes and so many other things happen. Having a good understanding and grip of Unity scripting will make everything easier. And everybody should know how to script, not just your programmers. Your artists should be able to understand it. They should be able to implement things on their own when they need to. There are a lot of visual things in particular that require a good deal of scripting. So we are going to go over the basics here. We're going to talk about input. We're going to talk about instantiating new objects. We're going to talk about physics and collisions. And we'll also throw in a little bit of debugging throughout as we go. So in Unity, we have a bunch of different things available to us to do our scripting, okay? And just to show you, all scripts in Unity are assets, okay? And I have a blank Unity project here, and I'm just going to start. I'm going to make a scripts folder, and this is where I'm going to put all of my scripts. And I can go back up to create, and I can create a new script. There are a couple options. There's a C# script, a JavaScript, or an editor test C# script. JavaScript is not real JavaScript, if you're familiar with what JavaScript is. It's actually called Unity script, and it is not the greatest and most fully featured thing. So we're just going to ignore it. It's more supported, and C# is more supported, I should say, and altogether it's a real programming language, for lack of a better phrase. So while it's not the most up-to-date version of C#, it is still fully featured. It integrates with the similar API to JavaScript, and even if you do wind up having to look up at the JavaScript someday, just keep that in mind. The API, the programming interface, the functions actually read very similar. And editor test, this is for unit testing, and we don't need to worry about that today. So I'm going to make a new C# script, and you see we get this pop-up here. I will call this Hello World. And then I will double-click it, and it will open it in my code editor. If you are on Windows, you can install Visual Studio. The Community Edition is free, and Unity can integrate with that as pretty much perfectly, seamlessly. It's the way to do it. And in fact, just recently, Unity made Visual Studio come with the installer. If you're on a Mac, you use a program called MonoDevelop. And MonoDevelop is still pretty good, though if you have access to a PC and can use Visual Studio, I highly recommend it for scripting. You can also use any text editor, but you won't be able to use the debugging features or have code completion. So your two best choices are Visual Studio and MonoDevelop. If you're on Windows, you also have access to MonoDevelop. So a script in Unity has a couple different things automatically. And you see that we have functions called start and update right away. Our class also derives something called MonoBehaviour. And we're going to break this down in a couple ways, okay? So start, alright, if we look at start, you can even see it gives us a little example of what it's for. It says use this for initialization. Now, a common question I see with Unity is where do we have a point of entry, okay? And when I say that is, where does the program start? Okay, so if you are in C or C++, right? Or Java, you're going to have something that looks something like int main, and you might have some args, okay? And then you're going to have do stuff, right? This is where your program lives. Well, Unity doesn't have that. Or I should say, Unity doesn't expose that to us. Unity is a closed-off system. Its programming interface is sort of a black box. Okay, you can do a lot of stuff with it, but you don't actually have access to the source code, so we don't see where the engine itself initializes. What we do have access to is individual game objects and components, and we can set up ways that these communicate with each other. And there are a lot of ways to do cross-entity communication, cross-component communication, whatever you want to call it, and that is the kind of the most important part, I think, of Unity scripting is understanding how to communicate between different components and game objects and then mutate them to do what you need them to do. So I'm going to go ahead and talk about this little diagram here. So in a game engine, in Unity, you have a couple different moments that happen on every single script. We have a wake, and a wake is something that's called when the object is created. When I say object, I mean the MonoBehaviour. A MonoBehaviour is something that can be attached as a component to a game object. So when the component is created, this will fire off. And awake is something that we call a callback. We also have the callback start and update, which we see here built in already. Start is what's going to get called right before the first update of the object. An update is something that's called every frame the object exists. So let me go ahead and hide this layer and draw a new thing here, okay? If we have a game engine, any game engine, in general they're going to follow this sort of layout, this paradigm, okay? And there's going to be some initialization, could be called init, could be main, right? This is what we talked about in our little text file, okay? So there's also going to be the game loop itself, okay? And the game loop will consist of some sort of logic update, okay? And then it will be drawing stuff to the screen, okay? There are so many more things that could happen, but barring a game with no visuals, or there are some ways to do this without a constant loop, there will always be some sort of logic and draw step. And these could either happen continuously, they could happen when they're needed to happen. There's a bunch of different ways it could happen. So inside your logic step, right, you're going to tell every single object, okay, to update. You're going to say, here we go, here's some stuff, update. And in usual game engines, you're actually going to pass in some information. You're going to pass in, like, game state stuff. Okay, so you can imagine, like, the score or the rules, even things like that. Things that other objects will need to know. Unity doesn't quite have this. We'll talk about that in a second. And then draw. Unity does not expose this to us automatically. We can do stuff when this step happens, but this step very much still happens. We just don't see it. And then there might be some exit stuff, you know, clean up, that kind of thing. So there's a million ways to make a game engine, but usually they're going to follow some sort of structure, not too dissimilar from this, okay? So Unity lets us extend something called MonoBehaviour, and when we do that, we can utilize the callbacks that makes available. And so the callbacks are specific points, and we talked about them here, okay, that things happen, okay? There's going to be a order of execution. And I'm going to go to the docs, okay, and I'm going to search for one of these. I will search for start, okay? And we have docs.unity3d.com. All right, you know what, I'm not going to search for start. Let's search for update. Okay, so there's going to be a million different things. But let's go into scripting, alright? And by the way, if you ever need to read more things, this has a ton of good stuff, okay? So we have this event functions page, and this actually, here we go, found update. Alright, so MonoBehaviour, okay? MonoBehaviour.update. If we look at the documentation for MonoBehaviour, we can actually see all of the different messages. They're called messages here, but you see that they're also called callbacks, and this is the usual term for them. So if you're having trouble finding stuff in the docs, Google will usually probably do a better job. It'll actually redirect you to the thing you're looking for. You can see there's a ton of them. And these are all different things we can use in our scripts. And today we're going to talk about a couple of them. We're going to talk about the collisions and triggers, and a couple of the input ones that we have available to us. But you can see things like update and start, and awake, okay? So these look a lot similar to what is happening in the game engine, but they're happening on a per object level. So in a normal update loop, right, you're passing in some sort of game logic to each object. You don't quite have that in Unity, so you're going to have to code your own ways to do that with the cross-entity communication that I was talking about earlier. So what if we just want to do hello world, though? Before we even get too far into it, let's just code something simple. Let's just code and print something to a console. If you're already a programmer, that's a really safe spot to start. If you're not a programmer, it's where you should always start with any new set of coding environments. So we have a couple options. Like I said, start is what happens. Start is what is called right before update is called for the first time. So this is going to get called once per component, okay? And the way we print something to the console in Unity is pretty simple. We just type, and let me zoom in a little bit. Alright, all we need to type is debug, okay? And again, if you're using MonoDevelop or Visual Studio, you'll get some of these autocomplete options, and you can always hit enter to complete it. We're going to type debug.log, and then we're going to give it a string, okay? And we're going to type in hello world. Okay, so now let me go back to the editor. And so some might think if I hit play, I should get a message in my console. And okay, so it's hit play. Let me take a look at my console. Alright, I don't have any message. Now, the reason that's happening is because I haven't attached the script to anything. Alright, so the scripts you make, they don't always have to be, but they usually will be components that you attach to game objects. And we talked about attaching different components like rigid body last time, and attaching scripts is very much the same way. I can drag and drop it from scripts onto the object, or I can click here and type what I'm looking for, hello world, and I can add it. And now you see I have it on here. Now if I hit play, you can see down here in the bottom left, or if I go back to the console, we see hello world. Let me make the console a little bit larger so that we can see it. Okay, hello world. Alright, and you can see that we get this debug message here, and it actually even tells us what line of code it was on, and I can click it and it'll take us right to it. So debug statements are really useful for basically just putting things to console, and you can use them to go right to where things happened in code. Now, there are other ways to print statements, okay? If you are in a class that's deriving MonoBehaviour, you do have the ability to use the function print. This is print. Okay, and now if I hit play, you'll see hello world, and this is print. So, what you may have noticed there is that I didn't have to do anything else. I could just hit play again. And so Unity does a couple things to make scripting really nice. Basically, every time you come back to the editor, if it detects changes in your scripts, it's going to go ahead and recompile what's new. So ordinarily, when you're making any program, right, you have to compile it, and then you can run it. The reason why Unity gets to stay live and get this live game update is because it's constantly recompiling the code that's different. So when I added this new line, it recompiled it. So if I get rid of this, when I go back to Unity, pay close attention to this. It might be hard to see, but you can see a circle in the bottom right of your editor, and that just means, hey, we're compiling. Stuff is happening. And, like, you can't hit play until it's done compiling. So, okay. So that's how we just print basic debug statements. And you can see that those statements only printed once. Okay? And that's okay. Right? That's what we wanted. We only wanted them to print once because they're in start. So what happens if now I put another print statement and I'm going to write update here? Okay? And now I hit play, let it compile. Alright, you see we're getting tons of these messages. And that's because update is being called every frame. So a frame in a game is just one step of the game execution. Okay? It doesn't have to be, like, game logic doesn't have to happen every frame. That's up to you as the developer. But this is, like, every update's going to then lead into kind of a redraw stuff to the screen kind of thing, at least in Unity. So, this is really sort of the main entry of code, right? Is making your own script that sets up the game, and you're going to feed that information other scripts. And that's kind of a more advanced topic, but it is important to keep in mind early on, and it's something to look up if you are really concerned about. So, how do we start using this code, right? We're printing stuff, okay? That's perfectly cool, but we want to start manipulating our game, and the place really to start there is input, okay? So I'm going to go ahead, I'm going to delete my hello world script, okay? And when I do this, first off, you'll see that I get this missing component. I'm just going to go ahead and remove it now. I don't want it anymore. And I'm going to make a new script, and I will just call this player controller, okay? And what we're going to do is we're just going to make something that moves around a cube. So to do that, first I'm going to make a cube that we can move around. Alright, make sure it says 0, 0, 0. Make sure that my camera can see it. And then I'm going to go ahead and open this player controller. And I'm going to have to reload all my scripts. And the old one that I had, whoop. I just open it again. Alright, there we go. Now I've got what I'm looking for. So I'm going to want to capture input, okay? And I'm going to put what I want to do here in comments. This is a nice thing to do if you're trying to figure out what you want to do. I want to capture inputs and then move a target based off that input. Okay? So first we need to define the target that we want to move. Okay? And there's a couple ways we could do that. And then we need to capture input. So let's just start with input, okay? Let's just grab some input and print something to the screen when that input happens. Unity makes it really easy to capture input. All we have to do is call the input module, alright? And it will give us a bunch of different ways to detect if a key is being held down. So I want to say when I press the space bar, print something to the screen. So I'm going to need to make a conditional, and then I'm going to say if input, alright, and you can see that I get this here, and this is a static class, or I should say this is a set of static functions, so you don't have to make an object. If you're a programmer, that'll make more sense. If you're not, don't worry about it. Just know that you can type input dot get key is what we're going to look at right now. So we have get key down, okay, and we have get key. This will tell us, is this key held down currently? Get key down will tell us, is this the first frame that the key has been held down? And get key up will tell us, was this a frame that the key was released? And so we only want this to trigger once, really. We're going to say if get key down, we're going to say key code dot space, okay? And this key code thing gives us access to one kind of for every different character you can imagine on the keyboard, okay? And this is not the optimal way to do input, but this is where we're going to start. If we get key code space, I'm just going to say spacebar. Let me go back. And don't forget to attach the script. And since we're eventually going to control the cube, I'm going to attach it to my cube. Now if I hit play, and I hit spacebar, you see I start getting this message in my console. And again, it's only when I press the button. It's not if I hold it down. So if I change this to get key, whoop, you see while I have it held down, it's being sent constantly. You can see that this is keeping count of how many times that message is being printed. So I'll leave this on key code down. Okay? And let's say we wanted to make it sort of like normal controls, right? We'd really use W, A, S, and D. So I'm going to make one for W, and then I'm going to use an else if input.get key down, whoop, key code dot S, and else if input.get key down, key code dot A, else if input dot get key down, key code dot D. So this is only one way to do it. This is not the best way to do it, not even close, and we will talk about how to improve this here in a second. But we've captured some input, okay? And now we need to do something when these are down, being pressed. And since we want movement to be constant, I'm just gonna get rid of down for a second. Okay, so when W is held, move up, move down, and move left, and move right. And in C#, the way you make comments is with // You can also do /*, and then you do a closing */, and then these are comments. Okay, so those things I'm running at the end of the line aren't affecting code at all. So, to move my object up, what do I need to do? Let me go back to Photoshop here. Alright? I have my cube, okay, which we're just going to be moving in two-dimensional space for right now, okay? I have my cube. Alright, it's my box. Okay, and I want to move him up this way, okay? This is when I press W, I want him to go up this way. And then we have our 4 other directions. Okay, so the way I do that is this cube has a component. We talked about it last week. This cube has a transform T, okay? And T can tell us the position, it can tell us the scale, and it can tell us the rotation. So if I wanted to move this up, right, I would say T.position, okay, in code. I want to add something to this, okay? And then what I want to do is I actually want to set the position to this value. So the way we do this is there's a couple different ways. Every MonoBehaviour can access a reference to the current game object and transform. Since we know that this is this is attached to our cube, we know that this transform is the cube. Now that won't always be the case, and we can specify different targets if we'd like. So I'm going to go ahead and make a variable called that is of type transform. Okay, and this matches the component called transform, and we're going to say target. Okay, the thing we want to move. Okay, and in start, we're just going to say target is going to equal this dot transform. Okay, so when we move the object, okay, first we want to get the position it's already at, and we'll say start position. Okay. Actually, we're gonna call this target position because we're gonna actually create the position we want it to move to. We're gonna move the object every frame, but we may move it by nothing. And we're gonna say target dot position. Okay. So if we want to move this guy up, right, we want to add an offset. Okay, and we're gonna make offset. You know what? I will call this start position then. All right. And then we'll just add the offset. I'm going to say this is going to be equal to vector3.0. Now, vector3.0, this is the same as typing new vector3, 0, 0. Okay? And there's an x, y, and a z component for vector3, though you can just define it with these two. But if you're just going to make a 0 vector, you can just do this. It's the same thing, just shorter. And then at the end of the frame, after I capture the input, okay, I'm going to say target.position equals start position plus offset, okay? And what this will do is this will update the location of the transform to its starting position plus the offset. And the offset is going to be defined here, okay? So if we say move up, we're going to say offset.y equals 1. And we're just going to move it up 1 unit. And offset.y equals -1. And then we're going to say offset.x equals -1. Okay, move it 1 to the left. And then offset.x equals 1. Now the way we have it written here is we will only ever move one direction at a time. Okay, so let's actually change this. We should be able to move up and down and left and right at the same time. So I'm just going to change my conditions like this. Alright, so they're two difference. So I can hold down A or D and W and S at the same time. Okay, so let's go back here. Alright. Let me hit play. Now, you can see it's going real fast. And now, why is this happening? Okay, it is moving the cube, though, so we've got movement happening. But it's going real fast. I only said move one unit at a time. This seems way too fast. Well, it's doing what we want it to, right? It is still moving. It's moving at exactly the speed we said to. But it's happening every frame. Okay, so let's talk about what's happening here. Okay, so whoop, lost there for a second. Let's say you have a frame rate of 60, so you have 60 FPS, okay? With our code, let's say you were holding down W for 1 second, okay? Since Unity is in meters, 1 unit equals 1 meter, right? In 1 second, since our frame rate is 60, and we were holding W, we're saying move up 1 unit, we're saying offset dot y equals 1, okay, and we're doing this 60 times in 1 second. So in 60 seconds, sorry, in 1 second, we're moving 60 meters, which is really fast. Okay, so we're moving 60 meters a second. That's pretty fast. 60 meters per second. So this is the same as the frame rate if we're moving at 1 unit per frame. Well, that's not helpful. What if somebody has a different computer? What if your computer can only do 30 frames per second? Well, now you're only moving 30 meters per second, so your controller feels slower. So how do we get around this? Okay, well, there's a way to do just that. So we have something called delta time. And in most game engines, this is actually passed into the update function itself. In Unity, it's not, though it's still very easily accessible. So time.delta time, okay? And this is exactly how we'll access it in code. Time.delta time is how we get around this problem. Okay, time.delta time, this is the time between updates. Okay, this is how long the last frame took to execute. And so if we multiply that by our speed, instead of it being 160 meters per second, it will be 1 meter per second. And so let's see this in action, though. So I want it to move 1 meter per second. But first off, you know what, let's just make this a variable that we can modify. So I'm going to make a public integer, and we'll call this speed. I'm going to set it to 1 for now, and then I'm going to copy this and replace it here. Okay, so we'll have negative speed. Okay, and what I want to do here is multiply this value by delta time. So, you know what, I'm going to, let's say, I'm going to make a float, alright? Floats and ints are probably the two most common numbers you'll use inside Unity, and I'm going to call this, like, speed actual. And this is going to be speed times time dot delta time. And once again, I'm just going to replace these guys. Okay, so now I'm going to... Now I'm going to hit play. Okay? And you'll see, okay, I'm moving a lot slower. But now I'm moving at a constant speed. No matter what my frame rate is now, I'm going to be moving at 1 meter per second. And that's because of time.delta time. Right? So, you can even see here, it says, it's the time in seconds it took to complete the last frame. So let's say, over a second, you wanted to move 100 meters, right? And just every frame, you're saying, move the proportion of a second that I moved, move that far, okay? So with 1, time.delta time, it's just giving me a percentage of the actual speed. So I made this variable modifiable, though, right? I made a public integer called speed. And look at this. Now, if I select my cube component and I look at the player controller, sorry, if I select my cube game object and look at the player controller components, I have speed here, and I can modify this. What if I set this to 5? Now this will basically look like 5, and I should be moving 5 meters per second. Look at that, I'm moving faster. And I can modify this at runtime. I can up this to 149, which will actually be faster than what we had before. Look at that. Okay? So, well, we've got our cube move into our input. So, let's do some more things, okay? What if we wanted to follow the cube wherever it goes? We could make code for the camera, right? What if I dragged the same player controller component? And what if I reused it? Okay, what if I made sure its speed was also 5, and now I hit play, okay? It's going to look like nothing's happening, and that's because the camera and cube are moving together perfectly, okay? This seems like a weird way to move the camera. It's kind of a waste, actually. Why would we do that when I can just do this? Let me remove that player controller. What if I just parent the camera to the cube? I have the same thing, okay? But the cube is now following me. This is a much better way to do it. Now, for some objects, things that things that rotate, for example, right? We may not want to do that, but for now, that's a good way to have our camera follow the cube. Now, I'm not going to do that because it looks like nothing's moving, and that's because our reference frame is moving with the object that's moving. So effectively, it looks like nothing's moving. Oops. So let's go back to this. All right, we got our cube moving 5 meters per second. Let's bump that up. Not 200. Sorry. Oop, that was an extra 10. Okay. 10. So this was not the best way to capture our input. This is actually kind of a bad way to do it. It took us so much more code. So Unity gives us a lot of ways to capture input. We have getKey, but there's also something, if I start typing it, you'll see it. There's something called getAxis, okay? Unity lets us define input axes in the editor, and then we can access these axes to generate our input, to get these values, okay? And so I'm going to show you how to do this. If we go up to Edit, input is a project setting. So Edit, Project Settings, Input. In the inspector now, we have something that we can expand called axes. And look at this. We have a bunch of axes built in by default with every new Unity project. We have a horizontal axis, we have a vertical axis, and then we actually have these duplicated sometimes. But if I expand these, you can see what it says. Horizontal. Okay, we have a negative button, we have a positive button, we have alternate buttons. And if you've ever played a video game that lets you customize your keybinds, this is kind of the standard it defines. And this sort of matches that. So this is saying we have an axis that will be activated towards negative and towards positive when we use left and right, those are arrow keys, or A and D. So an axis, okay, is just a value between -1 and 1. Oh, let's not make a new document. Okay, so let's say we have our horizontal input axis, okay? It's just this, okay? We have -1 and 1. This is when you hold A, and this is when you hold D. So let's say you're using a controller, right? Let's say you have an analog stick, okay? And you can move it this way, and you can move it this way, and this might be the extent it can move, so everything in between is going to be a number between -1 and 1. And this is what we call a normalized value, alright? And we'll talk about these more in depth later, but kind of anything that's between 0 and 1 is something that we can easily modify. We can easily multiply it by a scalar, which is just any number, right? And we get a perfectly proportional number. It's kind of like the delta time thing again, in a way. It's different, but kind of similar. So we can use these axes, we can use these input axes in our code, and it'll save us some time, okay? So we want to get the horizontal movement, and we'll call it H, alright? We're going to say input.getAxis, and it was called horizontal. Now, something you got to watch out for is these strings, okay? If I go back to Unity, look, I will copy and paste it. I usually do this just to be sure, because sometimes you'll type it in wrong, and I'll paste it. Okay, good. Had it right. And now I also want to get the vertical axis. Let me say input.getAxis vertical. Okay, so now I'm going to just delete this code. I don't need it anymore. And I'm going to say offset.x equals h, and I'm going to multiply it by our speed and by our speed actual, right? And I'm going to say offset.y is going to be our vertical times our speed actual, right? And this is going to be the axis times delta time times speed, okay? So now if I go back and I hit play, I actually should have the exact same thing. And you'll see that it actually accelerates and decelerates a little bit. Okay? Now, why is that happening? Well, let's investigate it with some debugging. Okay? There's a good reason why it happens. I'll give you the answer now. It is simulating, with my keyboard, it's simulating this on a controller axis. And Unity lets us say if we don't want that, and I'll show you how that works here in a second. But let's debug it. Let's see what's happening here, okay? So if you've used any IDE before, you've hopefully done some debugging. And so we can set breakpoints in Unity and then attach our editor and our code editor and the Unity editor itself. So I'm going to set a breakpoint in our update function so that I can then step through it. And then you'll see that there's this attach to Unity button. If you're using MonoDevelop, you will see a play symbol in the top left. But I'm going to go ahead, click this, and you'll see it kind of, it'll rebuild the project, and then it'll attach it. Now if I go, I can't go back to Unity, right? Because I did this while it was running. But I've already hit the breakpoint, okay? So now I can step through it. You know what? Just to show this more in depth, I'm going to actually stop the attach, and I'm going to stop the program, okay? Now I'll hit attach. Alright, so now I'm not hitting this breakpoint. Now if I hit play, okay, let's see what's happening. We have a breakpoint here. It hit start position. Okay. And we can go through a line at a time, and we can calculate all our different things. So, right, it's calculated our speed, and these should be returning 0 because I'm not holding any buttons down right now. Okay. And this will just keep going, right? Since I'm breaking an input every time, it'll keep going. So I do need to press some buttons, though. So, let's see, go back here, and alright, debugging input can be kind of difficult, but you can kind of see where I'm going with this. You know, we'll come back to the debugger later. Instead, it's a sloppy way to do it, but let's just print our values, okay? We'll just print H. And C# will know to convert this to a string automatically. And so if you modify a script, by the way, while it's running, you'll see the editor kind of freak out when you go back, and you'll just need to restart it. Okay, so now I'm printing out 0. Now if I hold down D, I want to see my horizontal input go towards 1. Okay? Now, if we were doing what we did before, we'd expect it to only do -1 and 1. But because it's simulating like a joystick, it actually interpolates towards that value. Okay? So, instead of using getAxis, I can use getAxis raw. Alright? And for a keyboard, this is a good way to do it. Oops. did I do something wrong? Oop, dot get access raw. Oh, alright. I guess it was just yelling at me for no reason. Anyway, so now with get access raw, if I keep this print, now it will print -1 and 1 every time. So for keyboard input, right, if you don't want that build-up, use get access raw. If you do, which I actually like in most instances, the acceleration and deceleration feels better to me as a player in most instances, you keep it. So, let's see, I gotta actually delete it. So with this, we have our very simple controller. And we do this with no conditionals. It's much shorter, and it works really nicely. So we can also set up our own axes, okay? You see this? We can add a 19th axis, and we can hit, we can call this new one, I don't know, hello. So we can start calling our axes whatever. You want to give them a descriptive name, of course. And positive, I'll say, is F, and you know what, that's all I'm going to leave it at. And so now, after I've edited the input, I'm just going to save the project. And, oh wow, I already forgot what I called it, so I'm going to go back. I have hello. I'm going to add in some more input gathering here. I'm going to say if input.getAxis, okay, hello. If this value is greater than 0, that means I'm holding it down. Okay, I'm just going to say print hi. And this is just to show you that you can make your own input axes. You can use any of these existing ones. Alright, see, there's printing hi. But making your own can be really useful as well.